We are live.
We are live.
We are live. Hello, Francesco. How are you?
Hello, I'm fine. How are you?
I am doing great. Thank you so much for giving us time for the second time. And this will be a special one. This is about your baby,
My
Puppini
baby,
Bridge.
Puppini Bridge, correct. Let's see,
Okay.
I'm checking if we are live. So there's something new today. We are also live on YouTube, right?
Yes, that is what I am testing now. I'm
Okay,
putting
cool.
it live on YouTube. Let's see if people can join or not. It will be a surprise for them as well. But
Okay,
let's
okay.
do that. Yeah. So tell me, how are you? How you been? I think it's been 6 months we did this graph theory with you,
hmm
and this is something you amazed me with your idea. But now we want to talk about your Papini Bridge. So
Yes.
I think let's again take a small opportunity to introduce yourself because I'm
Yeah,
sure.
sure. My name is Francesco Puppini, and I am Italian. You wouldn't say it from the name, but I am Italian. I've been in the field for a while, like since 2001. I've always enjoyed working with data. I started actually, I'm an engineer of telecommunications, and my first job was in Nokia. But in Nokia, they told me, okay, you're going to do a course of business objects. And I said, what is that? And then I started my career in data. So I didn't do one single day of telecommunications in my life. But I love working with data, also gives a lot of opportunities in every company. I work for Giorgio Armani, which wouldn't fit into my studies because I don't study fashion, but they have computers and databases. Data is everywhere. It's everywhere even more now with the AI. Knowledge of data opens a lot of doors to you. So yeah, that's where I am after 24 years. I'm still there working in data and I'm enjoying it a lot. One more thing, okay, say about myself, as you suggested, yeah, I wrote a book a few years ago called The Unified Star Schema. That book comes as a consequence of the things that I was seeing when I was working for various clients. I worked for more than 40 clients around all across Europe and a bit also in the US. So when I was working for clients, I was noticing always the same problem, the same identical problem everywhere, duplication of numbers. And people were saying the data source is wrong. And I said, no, guys, the data source, I can't judge if it's wrong or not. But what is for sure wrong is the way how you read it, because you're making combinations of tables and queries that are incompatible, tables and columns. And they said, why? What is this concept of incompatibility? How is that? And I realized that they all had the same problem: duplication of numbers, inconsistencies. And I went deep into the topic, and I realized that something new needed to be written, and a solution also needed to be written. That's why I wrote that book. That's about
Awesome.
me.
Awesome. So what you're saying is you have solved a problem, which is
Yep.
moreover, if I'm not wrong in a technical term, you solve the problem of Cartesian, where number numbers duplicate. Am I right to say that?
Yeah, it's not. Yeah, I don't want to go too much into detail, but yeah, one of the first misconceptions is that duplicate numbers are coming from Cartesian combinations. Definitely, if you have a Cartesian combination, like everything matching with everything, that's not reflecting the truth of your business, and that's creating duplications. But even in the absence of Cartesian combinations, exactly when you have as many rows as your rows of sales, you can still have duplications of numbers. Numbers are a very delicate thing. If you duplicate a product code, you can always count distinct. But if you duplicate a number, you cannot sum distinct, because you may send two invoices, both with the amount of 1,000 euros, and that makes 2,000. But if you do sum distinct, that brings back to 1,000. So numbers are very delicate. That's why even when you don't have a Cartesian explosion, but just a normal join between two tables that are in a one-to-many relationship, if a number, additive number like the invoice amount, is in the one side of the one-to-many relationship, that's what the market calls a fan trap or a fan out. And that's where we need a solution. It's not an error of data modeling. So it's simply a thing that happens everywhere, because businesses are like that. They have tables that have different numbers of rows, and when you put them together, you're risking to duplicate these numbers. So it all started with this fun trap thing. And I wanted to, first of all, define it, so give a definition of it. And then I wanted to solve it. And then I wanted to solve also the case of Cartesian, which is a further level of duplication.
Yeah, before we really jump into this Puppini bridge and technical part, in a holistic way, we have landing area, we have staging area, we have within, then we have data preparation area, and then we have semantic area. So where do your this unified data model sits? In which region? I'm assuming it's in semantic layer.
Yeah, I wanted to ask you to give it a guess. Exactly. So of course it's at the end of the chain. And let me tell you, the chain never ends. So the chain never ends. So that every person, every team that builds okay, now we are in the age of data product. So every team that builds a data product thinks that that's the final station, is the terminus of your bus ride. There's no terminus in data. Every time that someone is needing your data, it's not because they're watching it in awe with popcorn. Wow, that's a graph. No, they need your data because they need to do a further elaboration, mixing with other data and send it to someone else, and that someone else will also read the data and elaborate and send to someone else. So there's never an end point. So the data warehouse is designed in a way that there are this multi-tier architecture. So there is staging, core, and presentation. That's normally how I like to say it. And this presentation layer, also known as semantic layer sometimes, is supposed to be the last step of the data warehouse. However, for the people who did my job in business intelligence, the last stage of a data warehouse is the first stage of a further step sequence of steps of transformations, which happens in the business intelligence. Let it be a universe of business objects, let it be a script of click, let it be a script, a model of looker. There is always some additional transformation downstream of a data warehouse. So I thought that by building one final step of the data warehouse with a unified star schema would reduce the need for further transformations downstream. It will not eliminate them, but my goal was to reduce it at least for business users in a way that for simple questions, they don't have to go crazy. They just start from the unified star schema and they find most of the needed answers in that structure.
So thanks for confirming my concept as well, because I am also onto the same page that after landing and staging, there has to be a data preparation layer. And data preparation layer can be Bell and Mon 3NF, can be a data vault, can be a focal point, can be a anchor, whatever it can be. So that's a data preparation layer for me. And that is where I personally feel business should not hit. Reporting should not hit. There has to be a data preparation. After data preparation, there has to be a serving layer. And that serving layer, which is semantic, and you are right, the moment this preparation layer finishes, then there is no end. It depends on the business requirement, which kind of data you want. You want just joins, you can do it directly. You want some aggregations. Based on the aggregation, maybe you want to run some data science models. We don't know. So those chain is dependent on the business requirement. Okay, so we are good onto it. Before we again go into it, is this a virtual layer or you need to populate it?
That's an architectural choice. So there is a thing I like to share, which is quite important to understand this distinction. I've seen also in very, very large clients like large banks or car manufacturers, I've seen projects which had data that was not too big. So what is the definition of large data set versus small data set? Well, it all boils down to, does it fit into the memory of your business intelligence infrastructure? So that's to me the threshold. If you can fully download the whole thing, why not save physical? So when data is enough small to fit in your system for data analytics, save it physical. If your data has been already through a lot of transformation layers and you have a solid core layer like the data vault, then in data vault, it's quite a common practice to virtualize, to build views instead of tables. But that's an architectural choice that it all boils down to data volumes and other parameters that are up to the architect.
No, I'm absolutely with you. Reason being, correct me when we go into a technical, I understand this Puppini bridge sits right into the middle, and you end up having limited joins. So with this, you will have one or two or three joins. You will not end up having multiple joins, just like Snowflake or a 3NF. And I agree with you. Yeah, please go
Yeah.
ahead.
So you mean limited chains of joins? You have no chains of joins. So now, normally, if you think of a Snowflake schema, you have sales, clients, and countries. So it's a chain. Sales points to clients, clients points to country. So with the Puppini bridge, you have no more chains. Every table is connected only to the Puppini bridge.
Yeah, so it's a one join with every table, right? So,
Yeah.
and I agree, since we are in cloud environment, the more less joins you have, the less compute power you end up using it. Because see, the moment cloud comes in, there was a discussion happening. This DeepSeek came into picture,
Yeah,
right?
of course.
And why DeepSeek came into picture? Because there were the limitations on giving chips to Chinese, and
Yeah.
they came up with a solution. The
They were
last
forced to optimize.
yes, the last time we had an on-prem solution, we were restricted because of the hardware, so we used to optimize. But since we moved towards the cloud, those innovations has gone out of the box, because you know that if you need more power, it is just click away, right? So coming back to this, okay, before again we go into it, tell me about your journey with Bill and Mon. Somehow you have Bill and Mon indoors and co-writer with you. How did that go?
Sure. Yeah. Before the billion thing, I want to answer the thing about the joins. I don't want to take a merit on that. So in with the unified star schema, you have as many joins as many things you pull in. You pull 7 things in, you have 7 joins. So I'm not reducing the number of joins. If you do a denormalization, you have 0 joins. 0 joins is for sure more performing than 7 joins. So the thing that the merit that I want to take is the ease of interaction for business users. You still, I'm not a guru of performance optimization. That's where actually I'm pushing the unified star schema towards the community, because someone else who is dealing with very large data sets can come with suggestions. I'm open to that. I'm not even selling the unified star schema. It's there for free. Just you buy a book, on which I have very, very, very low earning, the price of a coffee probably. But a cappuccino, yeah, it's $4 per copy. So I really don't have any interest in selling the book or in selling anything. So it's a thing that I'm sharing, and I'm open to say, in this I did a very big improvement. In this, instead, I need your help. And that's always the message that I'm trying to give. So it's not optimizing performance. On the contrary, on the expense of a little bit of performance demand, it is optimizing the time of business users. And my story with Bilimon, well, it's very simple. When I went for the certification of Data Vault, I received this big book of Data Vault to study, so that I could prepare for the course and then go for the certification. And the foreword of the book was written by Bill Inman. And I said, is it that Bill Inman? So I went to search on LinkedIn, and he was there. I had no idea that Bill Inman, because it's a name that I knew from the beginning, from 2001, 2002. So I had no idea that he was still active on the market. For example, Kimball has retired. He's alive. He's probably in very good health, but he said enough of data. But Inman is still active in the market. He came to one of your episodes, and he's very curious, very open-minded. And I was surprised to see that I went to his LinkedIn page, and there was a post of 1 week before, and I said, "Wow, why not drop a line to this very important guy?" So I was not introduced by anyone. I just dropped a line to him, exactly like today someone is writing to me when they have ideas. It is happening, because people say, "Francesco, you're an innovator. How about this?" They show me things. So I wrote to him, and his reaction was, "Okay, first of all, this is my email address. Write to me, send me your ideas on an email, and then we can discuss it." And then he read my email, And he immediately replied, I like a lot your ideas. You should write some article or even a book. And then after a week, he said, you know what, we should write a book together. So it was his idea to write the book together because he said this way you will sell more copies. So I'll write the part one of the book, which is some history